So most of you found that epsilon delta problems weren't so bad, but you should be aware that the first question that's fair game is for me to ask you to describe in words what is epsilon, what is delta. Okay, so try to pause the video, write those out, try not to look at your notes. Okay, so if you're back, epsilon is the distance from the functional value to the limit. Okay, the skeptical mathematician tells you how far they want to see, or how close, I should say, they want to see that you can get to the limit, and then they give you that range in which they will say, okay, I'll believe you if you can get me this close to the limit. Okay, x, the distance, again, both of these are distances, which is why the answers to epsilon and delta are always positive. The distance to the x value. I give that full credit, but a better answer is to say the distance to the x value in order to satisfy the value of epsilon. That'd be a better answer, okay? But I'll just accept the distance to the x value. Okay, so I wanted to make sure I practiced a few examples here with negatives, right? People find those a little more challenging. So we're going to find the largest open interval that satisfies this epsilon of 0.05, and we're going to find delta. Okay, so I'm going to get you started, and then I hope you will pause the video and try this on your own. The part that messes people up the most, okay, so you get this 0.05. If you're going to make a mistake, it's usually applying the 0.05 to the wrong value, right? Do you add and subtract the 0.05 to the -21 or to the 5, right? Usually that's because there's only so many places you can mess up. Usually that is where people go wrong if they're going to go wrong. Okay, so again, pause the video, and where do you add and subtract the 0.05? Okay, and so remember, it is the functional value that the skeptical mathematician is interested in, the y values. They say, get me between these two y values. Okay, so you subtract 0.05 from -21 and add it to -21. Now, I'm going to do this all in one step, so I hope you don't mind that. I'm going to add 1 and then divide by -4, all in one step. So I'm dividing by a negative, right? I'm supposed to do something when I have an inequality and I divide by a negative. Okay, I'm supposed to flip the inequality symbol. Okay, so when I do that, okay, and I'll let you work the arithmetic along with me. I mean, hopefully that should be the easy part, the arithmetic. I'm going to get 5.0125 is greater than x is greater than, because I had to flip the sign because of the division by negative, 4.9875. And it looks very unnatural to have this, right? So what we want to do is we want to just flip it around, okay? Because you always want to have the smaller value on the left, okay, when you have an inequality. So just flip it around, okay? And that way you can have the less than symbols again, and that looks right, right? That looks natural and correct. So when I ask you what's the largest open interval, if that were part of the question, the largest open interval is where you tell the mathematician stand between these values. I know that they need to be close to 5, right? And that would be your clue if you did something wrong, right? Because you've got to have them standing close to whatever x is approaching. So here's the interval in which they would stand, right, in order to see the functional values in the range they gave me. So this answer goes here. right? The largest open interval, and then find delta. So delta is the actual distance from 5. Okay, so if we subtract 5 from everything, and because this is a linear function, right? Linear functions, we will get the same answer on either side. And so we will end up getting, let's see, put that over a little bit. We will end up getting negative 0.0125. So remember, it's delta is defined, it's a distance, right? It's so it by definition it is positive. 0.0125, and so that's our answer for delta, right? Find the value of delta. Don't have to make a decision because it's the same on both sides. So here's my answer for delta. Oh, wait, the one in there. Oh, gosh, sorry. 0.0125 is my answer for delta. So let's go down to the next example. So let's see if you can start this all by yourself. Okay, so we have, this is always our first step. Okay, so pause the video and you start this off all by yourself. Okay, so if you're back, you apply the 0.1 to the y value, to the functional value, and then you put the function in the middle. Okay, and it's not too bad of arithmetic here, but we're going to have to square all 3 sides because of the square root. Okay, so we do that. So I get, let's see, text box is easier. I get 15.21 is less than x plus 23 is less than 16.81. Okay, so to get x alone, I have to subtract 23 from all 3 sides, and I know I'm looking for values that are close to -7. So I'm going to have some negative values here. Right? So after subtracting 23 from all 3 sides, I get -7.79 is less than x is less than -6.19. Okay, so to find delta, right, I have to find the distance away from -7. So what I'm doing then here is I'm actually subtracting -7, right? So in the center here, I have to do x minus, right, like that, -7, right? Which we know is really adding 7. Okay, so you are going to add 7 on both sides, and then this is one of the problems where you have to make the choice. Okay, so over here, you get -0.79, right? And on this side, you get 8.1, okay? And if you get 2 different values, you pick the smaller, the one with the smaller absolute value, the smaller distance. Don't take the negative with it, okay? So remember, by definition, delta is positive, right? So delta is positive 0.79, okay? Because we take the smaller when there is a choice. All right, so usually if you apply the epsilon to the right value, usually this is a problem that every student gets right. So hopefully you'll get it correct on the test as well. So especially if you watch this. So thanks for watching.